8.3 Permutations involving identical objects. So anytime you're dealing with things that are the same object, we actually don't want to arrange those because they're the same thing. So there are 7 boxes of cereal on a shelf. 5 of them are bran cereal, 1 of them is puff wheat, and the other box is granola. How many ways can we arrange these? So we have 7 factorial ways to arrange all of the cereal. But because 5 of them are the same, we don't want to show the different ways to show the identical boxes of cereal in there. So I'm going to divide by 5 factorial for the amount of ways we can arrange those 5 boxes. So this would be 7 times 6 times 5 factorial. So it's 7 times 6, so there are 42 ways. I don't know why I wrote a Y. So that is what you do when things are identical. So using this logic, Julia's home is 3 blocks north, 5 blocks west. How many routes can she take from school? So let's use the idea of identical objects. Before I even touch that, there's 1, 2, 3, 4, 5 blocks east and 1, 2, 3 blocks south. So that's a total of 8 blocks. 5 east, 3 south. So if I did 8 factorial divided by 5 factorial, 3 factorial, type this all into your calculator or simplify, you would get 8 times 7 times 6 times 5 factorial. The 5's cancel, and we have 3 times 2 times 1, which is 6, so there are 56 ways. So that is how you can deal with the blocks. Another way you can deal with it is by charting it out. So she's only allowed to go east or south. So there is one way for her to get to this block. She would just have to walk east once. And there is one way to get to this block. There are 2 ways to get here. She could go right and down or down and right. There's no other ways. There's one way to get here, and there's one way to get here, and that's by walking down. And there's one way to get here, one way to get here, one way to get here, and one way to get here. And it's just by walking east. To get to this block, there are 3 ways. And to get to this block, there are 3 ways. And you can count them all out. But I'm also going to tell you that there are 4 ways to get here. And there are 6 ways to get here. So I want you to pause the video and I want you to try to fill it out all the way to the end, knowing that the answer should be 56, and see if you can figure out the pattern. So you should have got that there are 4 ways to go here, 10 ways to go here, 10 ways to get here, and 5 ways to get here. You then should have got 20, 15, and 6. Then you should have got 35, 31, and then you should have got 56. And then the pattern that you should have noticed is this plus this makes this. This plus this makes this. So this is a pretty special pattern. We often write it like this. And it has a name, and its name is Pascal's triangle. And we will be using this more in depth as we go. Okay, a little bit more complicated is this situation. So we have different cases here. So you can only go north and east. We're going from A to B. So we have 2 options. So the first case is if you go through this point. So that would be, it would look like this. And what would happen is you actually don't ever go through any of these points if you end up going through that top point. So that's our first option. Our second option is to go through this point. And if we do that, then we skip all of these and we just go through that point. So we're going to treat this as 2 different cases. oops, nope, 4, like that. We're going to treat it as two different cases. This is case 1, and this is case 2, and then we'll add them together. So if we look at the first section, this is north, 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 and then east, east. So it's a 5 total blocks divided by 3 norths and 2 easts. And we're going to multiply it by this one because it's part of the same situation that has 3 norths and 3 easts. So that's the same as 6 blocks and 3 factorial and 3 factorial. So that's root A. So if you type this all, might as well just type this all into your calculator. You can simplify as well. Let's just simplify. Don't be lazy. 5 times 4 times 3 factorial. And then we're going to do, why did I choose orange? 5 times 4 times 3 factorial over 3 factorial times 2 times 1. My 3's cancel. We have 5 divided by 2 is 2. So we're left with 5 times 2, which is 10. Then we have 6 times 5 times 4 times 3 factorial over 3 factorial. One of them cancels. And then we have 3 times 2 times 1. And 3 times 2 times 1 is 6. So we're left with 5 times 4, which is 20. So there's 200 possible routes for case 1. Now let's do case 2. We have 2 norths and 1, 2, 3 easts, which is a total of 5 blocks. So we have 5 factorial divided by 2 factorial, 3 factorial. And then we have 1, 2, 3, 4 norths and 2 easts. So that's 6 factorial divided by 4 factorial, 2 factorial. And now we can simplify. So we have 5 times 4 times 3 factorial divided by 2 times 1 times 3 factorial. The 2's cancel. And then we have 4 divided by 2 is 2. And we have 10 for that option. So same as the other one for that. Now we have 6 times 5 times 4 factorial over 4 factorial times 2 factorial. The 4's will cancel. And we can go 6 divided by 2 is 3. So we're left with 3 times 5, which is 15. So route B has 150 options. So altogether, including both cases, we have 200 plus 150. So there are 350 different routes you can take to get from A to B. So that is how you would do it with factorial notation. And the only way I can do it is if I draw out each picture. We may also do it using the Pascal's triangle. So 1 to get to here, 1 to get to here, 1 to get to here. 1 plus 1 is 2. 2 plus 1 is 3. 2 plus 1 is 3. 3 plus 1 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 4 plus 6 is 10. So there's 10 ways to get here, which is what we got. 10 ways to get to point A. And 10 ways to get to point B. We got that both ways. Alright, 10 times 10 is, or 10 plus 10 is 20. 10 to get to this point, it's also going to be 10, and to get to this point, it's also going to be 10, because you're just going right from there, and there's only one way to go right. Same with here, there's only one way to go up, and it's to go up. So there's 10 ways to get to all of those edges. Alright, 20 plus 10 is 30. 30 plus 10 is 40. 20 plus 10 is 30. 30 plus 10 is 40. 40 plus 10 is 50. 30 plus 30 is 60. 60 plus 40 is 100. 60 plus 40 is 100. 100 plus 100 is 200. 100 plus 150 is 150, and finally 150 plus 200 is 350. So quite obviously, this way is easier. It's a lot less work, but you should understand how to do it mathematically with factorials as well. Alright, last example, a kebab recipe requires 2 mushrooms, 2 shrimp, 2 cherry tomatoes, 2 zucchini slices. How many ways can we arrange it? So we have 2 plus 2 plus 2 plus 2, which is 8. So we have 8 factorial divided by 2 factorial, 2 factorial, 2 factorial, 2 factorial. And that seems like a lot of work, so I'm going to say 8 factorial divided by 2 to the power of 4. It's an easier way of writing that. And I can only do that because 2 factorial is just 2 times 1, which is just 2. And when I divide that, that's 2,520. I wouldn't bother canceling there because that's too much writing. Alright, so that's when you have identical objects.